Now we're going to begin exponentiation. And exponentiation is the first operator above the basic 4. Up until today, we have worked with steps 2 and 3 in the order of operations. We've been doing multiplying and dividing and adding and subtracting. Exponentiation is in line 1 of the order of operations. So we always conclude our work with exponents in line 1, and then we move into lines 2 and 3 when we're simplifying expressions. Now, exponentiation is an operation that requires a base and an exponent. And together, those result in a power. For instance, if our base is 3 and our exponent is 2, this is telling us to multiply the base to itself twice. So 3 with an exponent of 2 is 3 times 3, or 9. Here's the base, here's the exponent, and here's the power. So 9 is the second power of 3. One misconception that a lot of my students have is that exponent and power are the same thing, and they're not. Power is the result of having a base and an exponent. So I'm not going to be saying 3 to the second power because I think that's what confuses people. If I say to someone 3 to the second power, they assume that when I say second power, I'm referring to the exponent. And in fact, I'm referring to the 9, the result of multiplying the 3 twice. So I'll try not to say this, but it's not easy because I did for years and years. Now, on a calculator, you will have a power key. It often looks like an exponent. The most common one is probably this little caret key, which I guess doesn't look like an exponent. But on more recent calculators, there tends to be an X with a Y, or a Y with an X, or an X with a box, and there might be some other ones. If you have a calculator you're working with, please try to find one of these keys and then take a base of 3, and then usually you hit this key and then you put in the 2, and then when you hit equals, for instance, it'll give you a 9. You should memorize the first 11 perfect squares. That's what we call an exponent of 2. And these are not just important for chapters 4 and 5, but when we start working on roots in chapter 6, you'll need to be able to think of this instead of from left to right, from right to left. So in chapter 4, for instance, you need to think of this left to right. 5 squared can be replaced with 25. But in chapter 6, if you see the square root of 25, you need to know that that came from a base of 5, which was squared. So if you don't know these already, please memorize them. You'll need them now and later. You should also memorize the first few perfect cubes. With cubes, we have different answers if the base is positive or negative. With squares, everything's positive, because if you multiply 2 positives, it's positive. If you multiply 2 negatives, it's positive. But with cubes, they're different. For instance, 2 cubed is 8, but the quantity negative 2 cubed is negative 8. Let's conclude this video with one of the most confusing issues students have when they combine powers and integers. When people are evaluating powers, they confuse this issue right here. That is, are these the same? Are they different? If they're the same, what are they? If they're different, what are they? And this will get you for quite a while. It's just part of learning algebra. The other thing is, please notice it's the parentheses that make the difference. So when you're evaluating the base of a power, always use parentheses when you substitute the value for the base. Otherwise, you'll run into issues if the number you're substituting happens to be negative. Let's take the easiest one. This is saying you want the second power of -2. That means you'll multiply -2 twice. And when you do that, you'll get a +4. So this one is +4 right here. This one, only the 2 is the base, not the negative. And so this is actually thought of usually as -1 times 2 times 2, which is -1 times 4, -4. So this is -4, and this is +4. That concludes this first video on exponentiation.